All right, today we are adding and subtracting radicals with complex numbers involved. Okay, so when we add and subtract radicals, we do have to remember that they have to be like radicals. A like radical is the same radical. So they both have to be square roots, both cube roots, and the same thing inside of the same radicand, so like 3. So if this was 2 radical 3 plus 4 radical 3, these are like radicals. But if I added another or I subtracted a 4 radical 2, we couldn't combine that with the rest. So this particular answer would be 2 plus 4 is 6. We're just counting how many we have, so it's 6 radical 3, and then minus 4 radical 3. So that's the idea behind like radicals. I'm just going to smaller my thingy. Okay, so let's do this. First thing we got to do is reduce our radicals. So let's do that. So 36 reduced is just 6. 2 square root of negative 64, we have to make that negative 64, make that an I on the outside, and then take the square root. So it'd be 2I times 8, so it would be plus 16I. That's the first piece. And then this one is 2 times 7, or 14. And then take the I out here. And then this would be minus 5I. Now we just combine like terms like we normally would. You can line it up, so we can line it up like this. Or you can just combine like terms. You know, just say 6 and 14, okay? So it's 20 plus 11I. So i's work just like x's. You have 16 i's, you take away 5 of them, you have 11 left. And there we are. That's simplified. So similar example, square root of 16 is 4. And then we have to reduce this guy, so it's 2I times 9, so that's 18I. And then we're subtracting 100. The square root of 100 is 10. And then get rid of that guy, and it would be minus 2I. Now, since we're subtracting, it's 4 plus 18I minus this. So all of these signs gets changed. So it's negative 10 plus 2I, and then we just add normal. So 4 plus negative 10 is negative 6, and then 18 plus 2 is 20I. Good. I think I just fancied up my pen. I'm not sure. Okay, so then we have something like this. Now, this question and this question are apparently exactly the same. So I'm just going to get rid of this one and give you a new example. So let's say radical 72 minus the square root of negative 18. Oh, this should be negative also. And then plus the square root of 98. Okay, so we reduce these radicals. So it doesn't look exactly like that. It's not two complex numbers. It's just two pieces. 3 pieces. Just got to combine them, combine like terms. So there is a negative under the radical, so I make this positive and make it an I. Same with all these. I tend to do that all right to begin with. This one right here, no negative, so there's no I for that one. So we break this up into 2 radicals. So 36 and 2. Square root of 36 is 6. 6I radical 2. This may take you a little longer to figure out the perfect squares that go into it, but eventually you will. You know, I'm just going faster because, you know, I can. So the square root of 18 is 9 times 2. So the square root of 9 is 3, so it's minus 3I radical 2. And then we have this 98. Positive 98, so let's 2 radicals here. 98 is 49 times 2. So we have 7 radical 2. So these are all radical 2, so these are all like radicals, but they don't, these two are the two that have the imaginary part. So all of the weird pieces have to match. So with this one, it's just we're gonna combine the 6 and the negative 3 and get 3I radical 2. Combine these two. And I can't combine it with this one because it doesn't have an I. And you just have to keep that in mind when you're doing these. The rest of these are pretty straightforward. If they're already complex, then you just combine them. You just have to remember this is subtraction. So it's 2 plus 3i minus 5 minus 7i. So we have to change the signs and add. So I changed the sign. The 5 is now negative and the 7 is now positive. And just combine like terms. So it'd be negative 3 plus 10i. Done. Okay, and the rest of these are similar. I'm not quite sure what I'm going with here. Oh, this is the same. Oh, never. Whatever. So combine these. So this is just adding, so you can just do 9. For the love of all that's holy. So it's 9 minus 6i. You could line them up if you want, but it's unnecessary. All right, this one's the same as that one. I don't know, I must not have copied and pasted very well. So when we come down here, if we want to do the graphing thing again, so let's just talk about the graphing. If you want to graph these two, so 2 plus 4i, if I want to graph that, remember it's graphing 2 comma 4. So 2, 4 would be here, and then you have to do a little vector. Sorry, it's hard to do that without, oh, that was poor. And then negative 1 minus 3i, negative 1 minus 3i, that would go down here. For the, I don't know what my problem is. Anyway, sorry, that goes there. And then they want the sum of them. That is just really poor. So the sum of these is 2 plus negative 1 is, remember sum means add. So 1 plus 1i. So let's just change the color a little. So 1 and 1 is there. And then just draw the little arrow, and that's your the sum. So what quadrant is the sum in? The sum is in quadrant 1. Remember, this is 1, 2, 3, and 4. Oh boy. 4. All right. Have a wonderful day.